2. All right, so let's start. This is a review of yesterday. The first word that's on your notes is the word transversal. Can anybody with a raised hand tell me what transversal means? Eric. Yeah, one line that cuts through 2 or more other lines. You want to write that down. One line that cuts through 2 or more lines. It is one line that cuts through 2 or more other lines. It is one line that cuts through 2 or more lines. So on this picture, where's my transversal?
T. Oh, it's right
yeah, line T.
There is a senior high student council meeting.
All right, here's our transversal. Okay, first thing we need to find are corresponding angles. Can anybody explain to me where corresponding angles will be? Same spot at their intersection. Okay, so let's look at the 2 intersections we got going on here. All right, what's in the top left of the first intersection? 1. What's in the top left of the second intersection? 5. So 1 and 5 are going to be corresponding. All right, what about 2? 2's in the top right. What's in the top right of the other intersection? 6, I agree. Angle 3 is in the bottom left. So what's in the bottom left of the second intersection? 7. So that means angle 4 and angle 8. So these are our corresponding. Here's a sneak peek into what you're doing today. If they're in the same spot, what can you guess about their measures? They're going to be the same measure. Look at that. You already learned one of the 4 properties there. The same spot, they're going to end up being the same measure. The next one we're doing is alternate exterior. So in order to have alternate exterior, what helps me figure out what's exterior and what's interior? Draw our box. You connect the two lines. Draw your box. What's inside of the box is your interior. But what kind of are we finding right now? Interior? We're finding exterior. Good. So we want to be looking at the numbers 1, 2, 7, and 8. When it's saying alternating, what is it alternating over?
The line.
The transversal, which would be this line. We already spoke about this. I got to write the whole name. Just got to. Transversal, okay? So angle 1 is on the left side of the transversal. Now I got to come down here. And angle 8 would be on the right side. So it's alternating and exterior. So angles 1 and angle 8. What would the second pair be? 2. Angle 2 and angle 7. Good. Okay, quickly draw my box back. All right, so now when we do alternate interior, which angles are we looking at? Yeah, the inside, 3, 4, 5, 6. So let's start with 3. 3 is on the left side, because again, we're alternating. So what would be the alternate interior of 3? 6. So angle 3 and angle 6, which would mean 4 and 5. 4 and 5. 3 and 6, 4 and 5. Then we have one more. This is actually the hardest for most students. Are we looking outside or inside of the box? Inside. What does consecutive mean in real life? Back to back. In this case, it means on the same side of what? Of the transversal. I'm just going to write TRV. Transversal, is that okay?
Mm-hmm.
That's good. I don't want to write the... You get it. All right, so it's on the same side of the transversal, so either both on the left or both on the right. All right, so here's my transversal, okay? Angle 3 is on the interior. What is consecutive interior with 3? 5, I agree. They're both on the left side of the line. All right, so what about 4?
6.
And 6, I agree. So I have a question. Why can't 5 and 6 be consecutive interior?
Because they're not on the same side of the transversal.
They're not on the same side of the transversal. 5 is on the left, 6 is on the right. Perfect. All right, so this is a review of yesterday. Now we're just going to learn the properties of them. We already talked about corresponding. They're in the same spot. They're going to be the same measure. And you're going to learn about these as well. Okay? So that's what we're learning today. We're going to start on the next page. This is where you want to get a little colorful. So, there are 6 boxes. So, how many properties are there total? 6. Do any of these look like super familiar like we did them last chapter or the chapter before?
Yep.
Yeah, the first 2. Vertical and linear. Okay? What picture, and if you can read it all, you'd be able to know. This top picture, angle 1 and 2, what relationship do angle 1 and 2 have together? They're linear. I don't care about how much they measure. They're a linear pair. Look at that. Good job, guys. Give yourselves a clap. Good job. They are supplementary, but their relationship is that they're a linear pair. Listen, I had classes all day today, and I asked them. And as I read the board, they were shouting out all these weird words. Had nothing to do with linear pairs. This is like 6 times over here. So this is a linear pair. Linear pairs, like RJ said, they are supplementary. So here's what I want you to write in the linear pair box. It is the top right box. I want you to write supplementary, and then I want you to highlight it. Supplementary, and then I want you to highlight it. Once you have highlighted that they're supplementary, it's actually harder to color this one in if you remember yesterday. Because for every angle, it's a part of 2 different linear pairs. Okay, if you remember, angle 1 is linear with angle 2. But what else is angle 1 linear with? Angle 3. Okay, what about angle 2? It is linear with angle 1, but it's also linear with angle 4. So every angle can be a linear pair with the angle that it's directly next to. So they're also supplementary to the angle they're next to. Okay? So that is the property of linear pair. There's not much to color on that because you would have a big rainbow mess. But the next one, what kind of angles are these on my picture? Vertical. It also says it right there. Okay, so vertical angles, let's look at the theorem. It's called vertical angles congruence theorem. So what do we think about vertical angles? They're congruent. I would write that and highlight it in the vertical box. It's extremely important. Vertical angles are congruent. So in your box, this is where your colors come in. All right, angle 1 in your picture. Okay, I'm just going to draw on the top. Angle 1 will be vertical with what other angle?
4.
Angle 1 and angle, 4, I agree. What about angle 2? Angle 3, those are vertical. Angle 5. Angle 8. And last, angle 6 and angle 7. Exactly. So these are vertical. Vertical angles in linear pairs are the reason that if you knew one angle out of a transversal, if I knew the measure of angle 2, I would know the measure of every single other angle in this transversal, okay? Because they would either be vertical angles or linear pairs. And we will do that in a couple of minutes, okay? We're going to move on, but before we do, I have one more thing I want you to do, okay? Because we're going to learn about different properties But the first thing that has to happen that you have to know is that these next 4 properties are only applied if you have 2 parallel lines. So here's what I've had my classes before do. Can I borrow this? Okay. So I had them highlight these 4 boxes. I'm sure that you'd be more meticulous. I'm so sorry. I had them highlight these 4 boxes, these next 4, and write that they are only applicable, or you can only apply if the lines are parallel. Okay? If they're not parallel, then these properties don't happen. Okay? So the next 4 I would highlight. They only are applied if the lines are parallel. And I'll show you what I mean by that after this picture. All right, so let's look. It says if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are what? Congruent. In the box of corresponding angles, they are congruent. And I would highlight that. Corresponding angles are congruent. How do I know that these 2 lines in my first picture, not the one that I've drawn, how do I know that they're congruent? Or sorry, that they're parallel? The triangles, okay? If you don't have the triangles, here's what you can't do. Okay? These 2 pairs are corresponding angles. Do we agree? They're both in the top left. We agree, yes or no? Okay? Do they look like they would be the same measure?
Yes.
No. Let me make it more predominant. Let's see. Kind of like that, I guess. Okay, because these 2 lines are not parallel, these 2 will not be the same measure. That's why I'm telling you these only apply if these 2 lines are parallel. Okay? Otherwise, it doesn't apply. Okay? In the next couple of sections, you'll actually be proving that they're parallel using these properties. It's not as hard as it sounds, I promise. But that's why I'm telling you that. Okay? So, for yours, the corresponding angles, looking at your paper now, okay? 1 is corresponding with what angle? 5. 2 is corresponding with 6. 3 is corresponding with 7. 4 is corresponding with 8. If you don't want to highlight all of them, maybe just highlight 1 pair of them. So when you go back to your notes, you can just look at it and remind yourself. Now we're going to talk about alternate interior angles. So again, if we have 2 parallel lines that are cut by a transversal, the alternate interior angles are congruent. So at alternate interior angles, you want to write that they are congruent. So on your paper, which will be alternate interior? 3 and 6, 4 and 5. So 3 and 6, 4 and 5. What you asking? All right, here we go. If alternate interior angles are congruent, what else can we guess are congruent? Alternate exterior are also congruent. So if 2 parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. So exterior would be here. Yeah. And then, what else? 2 and 7. Yeah. 5 is still inside of the 2 lines. So 1 and 8, 2 and 7. then the last, and I will explain why this is the kind of the outlier, the weird one. Consecutive interior angles, if two parallel lines are cut by a transversal, then the pair of consecutive interior angles are supplementary. So this is the last one. It is supplementary. I will explain to you why. Pick a number between 1 and 100.
42.
54.
Preferably an easy one. 50, sure. Alright, so, listen. If this one is 50, what would the measure of the angle right next to it be? 130. Why?
Because 180 minus.
Because they're a linear pair. Yeah, they're a straight line. And then it's 180 minus 50. Good. 50 would be here. Its alternate interior angle would be here. So what would the measure of its alternate interior angle be? 50, because alternate interior are congruent. Then if this one is 50, what's the measure of this one? 130. This is exactly why consecutive interior, which would be these two, are supplementary. That makes sense? Because of this setup we got here. And I'm going to teach you what I call the zigzag. All right? So, here's what I want to point out to you in your notes, because I'm a very meticulous person. If you look at them, how many of these were supplementary? Two of them. Which two were supplementary?
Linear pair.
Linear pair and consecutive interior. Do you see how they have a darker box around them? Isn't it on purpose? Those are the only two that are supplementary. So what I tell students, okay, is to remember that those two are supplementary. The rest of them are congruent. Okay, and that's a little easier to remember. You got two. Linear pair, which we should technically already have known that is supplementary. And then the new one would be consecutive interior. All right, let's do some problems. Let's flip to the next page. This is where I teach my students the zigzag. This is not in a math book anywhere, but it just is helpful, especially to those who are not great with the relationships between angles. Okay? Here's what the zigzag is. What relationship does 120 have with angle 4? They're vertical, which makes them congruent. Okay, so what's the measure of angle 4? 120. What relationship does 4 and 5 have? Relationship, not measure. They're alternate interior, which makes their measures congruent. Congruent. Alternate interior are congruent. So that means what's the measure of angle 5? 120. And then what's the relationship between 7 and 8? They're vertical, which makes them, again, congruent. So here's why I call it the zigzag. Okay, look. Zigzag across, zigzag across, zigzag across. We do the same thing with the other angle. That's why I'm telling you, if you know one of these, you know every single other angle on this picture. Okay? Are we all okay with the 120s?
Yes.
How you would write your answer, you would say the measure of angles 4, 5, and 8 equal 120. Because I love you, but I don't want to have to read your handwriting through that picture. All right, we're going to do the same thing. Let's find angle 3 first. Okay, what relationship does angle 3 have with 120? Why are they supplementary? What relationship is there? It's one of the 6. They're a linear pair.
Oh.
They're a linear pair, which makes them supplementary. Sorry if you can't see my purple. It's right here. All right, so then what is 180 minus 120? 60. So that means the measure of angle 3 is 60. Okay, then where would we go next for our zigzag? The 2, which would be also 60. After this, we'd go to 7, which is also 60. Then we go to 6, which is also 60. There's your zigzag. So again, your final answer will look like the measure of angles 3, 2, 7, and 6 are 60. Ta-da! All right, let's do another. This one, we're solving for the value of what? X. I will show you 2 different ways to do this. One of the 2 ways. All right, so here's what I tell students. Does 115 have a relationship with x plus 5? It doesn't. Okay? It's not alternate interior. It's not corresponding. It's not any of those. Okay? So here's where the zigzag would help. What's the measure of angle 4? 115. Which would mean the measure of this angle is 115. This angle would be 115. So does x plus 5 equal 115? It doesn't. Okay? No. So here's one of the two things that you can do. You can look at this problem and say that these two angles come together. They form an upside down T. So what does that make them? A linear pair, which is supplementary. So we can add them up. So add 115 plus x plus 5. Add them together and they equal 180. And then there's also a second option if you want to pause. Okay, that's option number 1. This is the one I do most often in class because some people don't think like geometry here. If they form 180 degrees together and 115 is already taken up, what is the measure of this angle going to be? 65. Because 180 minus 115 is 65. So your second option would be set up this equation. Okay? My question isn't what's the measure of this angle because we'd be like it's 65. No. We're trying to find the measure of angle x. If you do it this way or if you do it this way, you will get the same exact answer. The reason I prefer to show people this one is because some people don't think in terms of 180. They don't think in terms of math. So to me, I just always tell them they either equal each other or they add up and equal 180. Okay? But I don't mind if you do it this way. I, as a math teacher, do it this way. Okay? Does that make sense? We're going to continue with this one, and you're going to find we're going to get the same answer. Okay? What's 115 plus 5? 120. Then we still have plus x equals 180. All right, what will we do next? Subtract 120. And our answer is 60. All right, you would have gotten the same exact answer. We would have subtracted 5, and 65 minus 5 is 60. Same thing. Okay? So I'm content with either way. Questions on this example? Okay, let's go. Next one. Whenever you see this number, you see this red 1, okay? It's kind of like a hint to try to help you with the problem. You can use it if you would like, because what relationship does angle 1 have with 7x plus 9?
Alternate exterior.
They're alternate exterior, which means they're going to be congruent. So if you really found out what angle 1 was, you could set it equal to 7x plus 9, okay? Or you can do the zigzag, which is what a lot of my students just do. 136 means 136 is going to be here. Go across the transversal, 136 is here. 136 is here. So again, this is where there are multiple ways to solve this. All right? Does 7x plus 9 equal 136? No, it doesn't. Okay? 136 would have fallen on this if it was. Okay? So you can do one of two things. We can add them up. Okay, this is where you can part your ways. I would add them up, 136 plus 7x plus 9. What will they equal? 180. Okay, or you can figure out what this equals and set it equal to that. Okay, 7x plus 9. Yes, sir?
For this decimal, they all equal up to 180? Will they all be similar?
Or they'll equal each other. So no. The one and two are the options. It just so happens that none of these have, like if 136 fell on this, then it would equal 136. Good question. Yes, dear?
Is everyone going to be able to use a calculator?
When are you not allowed to use a calculator in my class? Review quizzes.
Okay.
All right, what's 136 plus 9?
145.
145 plus 7x equals 180. Subtract 145. What's 180 minus 145? 35. Divide by 7. What does x equal? 5. Did anybody do it the other way? Okay, what did you get 7x plus 9 to equal? 44, yes. Reason being, 180 minus 136. Sorry, that's a 6 on my picture. is 44. You got the same answer, yes? 5? Okay, I'm content with either way. Questions, comments, concerns? Okay. Proving, we got 2 more things to do and then we're finished. All right. Proving the alternate interior angles theorem. So what are we trying to prove here? What does the alternate interior angles theorem say? That they're what?
Two arrow lines are transversal.
Then
Alternate interior angles
alternate interior angles
are congruent.
are congruent. That's the point blank. Okay, so what 2 angles are we trying to prove are congruent?
1, 2.
Well, no, just 1 and 2. 1 and 2 are alternate interior. So we're trying to prove that these 2 are congruent to each other. Here's how I would like you to do it. List all of the relationships that you see in this picture. And I'll show you why we do it at the end. We're up here. All right, so what, other than 1 and 2, here's my thing. We can't say angles 1 and angle 2 are congruent because of the alternate interior angles theorem. Because we're trying to prove it. Can you ever use the word in the definition? No. If I wanted you to explain to me how 1 plus 2 is 3, and you said because 1 plus 2 is 3, is that explaining it?
No.
No, okay? It's not proving it to me at all. You literally just said what I said. So we need to figure out all of the other relationships in this picture so that we can prove these 2. All right, so what other 2 angles can we state a relationship for besides 1 and 2? Sure, 2 and 3. So we're going to write over here, angles 2 and angle 3. What are they? Our vertical angles, which makes them congruent. Our vertical and congruent. I'm going to write the symbol. So we got that relationship going for us. All right, so we have 2 and 3. What other relationship could we state besides 1 and 2? 1 and 3. What relationship does angle 1 and angle 3 have? They're what? They're corresponding. In order for them to be consecutive interior, they'd both have to be on the inside. Corresponding angles are what? Are they supplementary or congruent? Congruent. So, and congruent. So, therefore, we're going to make a conclusion based on what we just figured out. Here's what this has to do with real life. Okay? If Emily is the same age as Eric, Eric is the same age as Maya, what do we know about Emily and Maya?
Same age.
They're the same age. So let's look at this. 2 and 3 are the same measure because they're congruent. Okay, we all agree? We could pick a random number off the top of our head, whatever it is, they're both the same measure. Okay? We also know 1 and 3 are congruent. They're the same measure. So if 2 and 3 and 1 and 3 are the same measure,
Then 1 and 2.
1 and 2 are the same measure. So therefore, angles 1 and angles 2 are congruent. Okay, you prove it by just stating the relationships you see in the picture.
Is that a law syllogism?
Law syllogism, you'd have to have conditional sentences. This is more so like the transitive property. Yes, ma'am.
Kind of like this one is seeing how you're repeating in both the congruent, so it would be the number that doesn't repeat.
Yep. That's a transitive property. All right, we got one more. If you flip your page completely, you'll find a picture that looks like this. It is smaller, or mine is smaller. Lo siento. So the reason I did this is because up until now, none of our angles have equaled each other, and so all of my students were adding things up, setting them equal to 180 without even thinking about them. We can do this one of 2 ways. What relationship does this angle up here have with this angle down here? They're alternate exterior, which means that they're congruent, which means that he's saying it, start with me, they equal each other. You could also have done the zigzag. Okay, this is 90, which means across from it is 90, which means across from that is 90, which means this is equal to 90. So either way you had done it, 21x plus 6 will equal 90. Is everyone okay with that fact? Okay, so then we would solve. So we get 84 equals 21x. Divide by 21. What does x equal? 4.